In this unit, we'll be dealing with variables expressions and all sorts of different powers with variables expressions, and we'll have to be able to manipulate them and to be able to break them apart with addition or multiplication, in particular multiplication, because we will be factoring many of these. So we need to make sure we understand what a monomial and a polynomial is. A monomial term is when we have any algebraic expression that is grouped together by multiplication. That is a monomial term. Anything that's connected by multiplication is a monomial term. And we have our variable parts here. The R and the H represent the variable parts. And the number part, or in this case pi, is our coefficient. So pi is a number. So that number part represents the coefficient. A polynomial is when we have more than one term. So this happens to be the volume of a cylinder calculation or formula, and this formula is a monomial term. The surface area of a cylinder is considered a polynomial because it has two pieces that are connected by addition. When we have more than one part that can't be combined together, this is considered a polynomial. So polynomial has a variable part in each of its monomial pieces. There's my variable part. It has a power on it. The 2 pi represents the coefficient. That's the number part. Here the variable part is r times h. That's my variable part. The 2 pi represents the coefficient. And what we can do with these is we need to make sure we understand how to manipulate this. We can do things like factoring. We can look for greatest common factors of these two terms and factor. So for example, 2 pi and r is common to both of these. So I can factor 2 pi and r, and I'm left with 1r over here because I had 2 r's, and plus, I need to make sure I keep track of my addition, and we'd have an h left over here. So this expression, factored expression, is equivalent to the original expression. So we can use these polynomial expressions to do things like calculate volume and surface area. So for example, if I want to calculate the volume of this Coke can that has 12 centimeters high and a radius of 3.2 centimeters, the volume can be calculated with pi times the radius squared times the height. And when we do that, we can just plug that into our calculator and we can just do the calculation. So 3.2 squared times 12 times pi gives me a volume of 386.04 centimeters cubed. Okay, because I square the centimeters here to get area. I multiply by a centimeter's height. That's going to give me cubes. The surface area can be found by using the other formula. So surface area is equal to 2 pi times 3.2 plus 2 pi times 3.2 times 12. And again, note that if I use this formula, I would get the exact same result. So putting that all together, 2 times pi times 3.2 gives me 20.11. And that's going to be, that will be the surface area. Oh, sorry, this is 2 pi r squared. I just need to do that again. 2 times pi times 3.2 squared. So make sure you square the 3.2 first. And I end up with 64.339. So I'm going to round that to 34 centimeters squared plus 2 times pi times 3.2 times 12, and that's going to give me 241.27 centimeters squared. Adding that together, I end up with 305.6 1 centimeters squared of surface area. So these are polynomial terms. This is volume is a monomial term. The surface area is a polynomial term, and these formulas we can use to solve problems.